Imagine being able to convert any image from this to this. This is called edge detection, and we will be doing this using programming. For this algorithm, I will be using Python because of its ease of use and the availability of something called the NumPy array. We need an image format to work with. I will be using the ppm file format because it's easy to use when compared to other file types. Just take a look at this. This is what a JPG or PNG file looks like in a notepad, and this is what a ppm file looks like in a notepad. I would not be explaining how the entire ppm image file system works in this video, but it is very simple. All you need to know is that every image is a matrix of pixels, and each pixel has its own color, represented by red, green, blue values. To write a 4x4 ppm image file, we take the 4x4 matrix and assign a RGB value for each of the rows and columns. Now let's talk about the steps of edge detection. To be specific, the canny edge detection. The first thing is to convert any image, if colored, into a grayscale version of that image. The reason for this is we really don't need the color of an image when tracing out the edges. With the ppm file format, we can do this by changing the ppm file to a PGM version, which is basically the grayscale version of ppm. Because edge detection is sensitive to noise, the first thing we need to do is to smooth out the image using the smoothing kernel, and this is called Gaussian blur. The smoothing kernel is a matrix that, when applied to another matrix, in this case our image, would use the weighted average of neighboring observed data to balance the matrix, therefore making our image smooth. Next, we need to construct an array of gradient vectors that contain the change in x and y axis of the image using this formula. After this, we calculate the magnitude of each gradient vector using this easy formula. Once these two steps are done, we can say that we have achieved some level of edge detection. This almost does the job, but we still have a lot of noise and some of the edges are too thick. We want more defined edges, and here comes the edge thinning routine. To get thinner edges, we need to get a little bit matsy. For the image on the screen, we have a vertical edge. We want to suppress the edge to give a finer edge. We suppress all the pixels except for the brightest pixel in the horizontal direction. This means we suppress all pixels except for the brightest pixels perpendicular to the direction of our edge. At this point, you're probably wondering why this works and you still don't understand what is going on. The image on screen right now shows a bright vertical white pixel with surrounding gray pixels. To get the effect of a thinner edge, we need to remove the gray pixels and leave the white pixels alone. This exactly points to the jargon I said before. We suppress all the pixels except for the pixels perpendicular to the direction of our edge. Since the gradient vector of a pixel points in the position of its maximum rate of change, we instantly know which direction to suppress. To calculate the direction of each pixel, we do need to get the arctan of the change in y over the change in x. This will give us a degree, and depending on which degree we get, we know the direction at which we will thin the edges. And one more thing we have to do is to round each edge to its nearest multiple of 45. At the end, we will be left with angles that are either 0, 45 or 135. This way, any angle that equals to 0, we compare to the left and right. If the angle equals 45, we compare to the upper right and lower left. Any angle equal to 90 are compared to the above and below pixels, and angles equals to 135 are compared to the upper left and lower right pixels. So basically all adjacent pixels. After the last process of thinning the edges, we need to suppress the noise in the picture to single out our edges. If you really think about it, all we want to do is remove stray pixels. To do this, we need to set thresholds of the pixels that we believe are weak. The threshold can vary from picture to picture depending on how much noise you want to eliminate. For For now, we set the low threshold between 5 to 10% of the max pixel and a high threshold between 10 to 20% of the max pixel. We would remove image pixels that are lower than our low threshold, and for any image pixels that is between our low and high threshold, we consider them weak, and we have to check if any of the 8 neighbors of that pixel is above the high threshold. If that is not the case, we set the image pixel to 0. And those are all the steps, guys. As you can see, the steps are quite intuitive and easy to understand. Here are a few images that I tested. If this video entertained or helped you in any way, it would really help if you support the channel by leaving a like, subscribing, sharing, and also dropping a comment if you would like to leave any. Thanks for watching.